All right, let's get started. I'm sure people will filter in a bit more. This lecture might not be the full lecture period, so we'll see. Okay, so first thing, your assignment is due tonight. Does anyone have any last minute questions about it or about submitting it? Has anyone actually submitted it? A few people, okay. It was fine? Okay. It's our first time using Moodle to collect assignments, so it looked pretty intuitive, but anyways, it's good to know. Okay, and then of course, if you want to slip, then you would have till Friday. Yeah, so that's the plan. So like I say, we never used Moodle before, so I think it seems from what I've read, there is a way to give your grades back to you through Moodle itself. And if that's the case, then that will be our preference. So yeah, so I can't say 100% because we haven't done it yet, but the intention definitely is to get it back to you. You'll get it digitally one way or another. So the only alternative would be that you get it emailed to you. And you won't have like a lot of comments. So it'll just sort of be your grade. And if there are deductions, there might be just like a few points about the deductions themselves. So it's because there's like 100 and something students. I know it doesn't look like it, but it takes the TA a long time, right? 4 pages times 100 is 400 pages, and so they can't write down every little thing they see. So they try and give you a summary. He'll give you a summary judgment. When you get your marks back, you can, if you want to dispute it, follow up with the TA himself. I don't get involved in that. Unless if you can't resolve it with the TA, then you can come to me and I'll be the final adjudicator. But usually, if you just converse with the TA, you'll learn what the issue is, and it's usually not a problem in the end. Okay, anything else about the assignment? Okay, so just 2 scheduling things. I'll try and mention this at the end of class, but since it's up here, so next week is reading week. So this is a new thing at Concordia. We always had a reading week in the winter term. Now we have one in the fall term as well. So that means you have no classes. So you may have midterms or something like that. I don't know. But anyways, it'll give you a chance to catch up on things. So there'll be no lecture next week. The next thing that I'll say is not 100%, but there's a good chance, 75% chance that I won't be here on the following lecture, lecture 6. So I'll officially tell you over email or through Moodle messaging when it's the case. But since I'm pretty sure that I'll be gone, I'll just tell you what I plan on doing, and then I'll confirm it by email. But what I'll do is I'll pre-record lecture 6. And since lecture 7 is an extension of lecture 6, I'll actually just put them both together. So I'll give you a big, long lecture. It'll be a little longer than one lecture. It'll be like a lecture and a half. And I'll give it all to you for the week of lecture 6. And then on lecture 7, instead of having the lecture, we'll still meet in class, but it'll just be question and answer. So any questions you had about the lecture, that kind of thing, then you can come. I'll still record it and I'll put it up on YouTube. Okay, so 75% chance that happens, 25% chance it'll just be like normal. You'll come to class and we'll do the lectures in person. Okay, so I think that's it logistically, unless if there's any other questions. Okay. All right, so we're going to just wrap up the attack tree on HTTPS. There's not a lot of topics left. There's only the sort of the bottom part of the tree to go through. And so I'll pick it up. I know we talked through some of these slides last time, but I did it kind of at a rush because I wasn't sure how far I would get. So I'll just go over revocation again and talk about it a little more slowly. Okay, so let's say that an adversary is able to break into a server. Server has a certificate. Certificate contains their public key. Their public key is a public value, but there's a corresponding key that goes with it that's a secret key. So to use a public key, you need the secret key to go along with it. Okay? So probably the worst thing that can happen to you in terms of a breach of your SSL would be someone breaks in and steals your private key or your secret key that goes along with it. Okay? If they have your secret key, they can do digital signatures. If they can do digital signatures, they can complete the handshake of setting up a secure tunnel. And you're going to think, the browser's going to think that you're talking to the real website because that key's involved in setting the tunnel up. but in reality, you're talking to the adversary because the adversary has a copy of the key. Okay? So back to the root node of the attack tree. If you're in the middle, you're already in the middle. Okay? So you'll see the client, like say, connecting to Google and saying, hi, I want to talk HTTPS. Then you'll just jump in the middle and say, oh, I'm Google, here's my certificate. You can do all the signatures and all of that things. You give the real certificate. You have the key for it anyways. So you give them actually, there's nothing wrong with the certificate. Certificate's completely valid. It's just two people have the key that's inside the certificate. And then you just start signing things. Okay? Now let's say Google notices it. So how do they notice it? Well, Google could notice it because they're big enough, they have a browser, they have a website. Anyone that goes to Chrome and they don't recognize the certificate that's being used, it's going to phone home to the security team at Google. In terms of me and you, let's say we have personal websites. How would we figure out if someone was impersonating us with our certificate? We might not. Okay, we might never know that it's happening because we're not in the loop of that communication. We might know it or we might just be concerned about it because we see that someone breached our server. So we don't know for sure, did they get the key or not? We don't know, but just to be safe, let's get a new certificate, okay? And then the third thing is the CA might realize that there was a breach as well. So sometimes these certificates, it's not so much that someone steals the key, it's that someone games the certificate issuing process, the CA realizes it, and then they want to cancel all the certificates that they issued, okay? So anyways, in any case, we're in this scenario. The adversary has a stolen key, and so they can immediately start intercepting traffic by setting up a tunnel between the adversary and them, and then they can make the corresponding tunnel from them to the website, and they can just relay information between them. And in the middle, they see it decrypted, so they can change it or read it, depending on what they want to do. Okay, so the idea is that we need a way to cancel a certificate. Okay, so you could just say, well, I'll get a new certificate. Okay, you can get a new certificate, and it's true that the adversary doesn't have your new certificate. Okay, but now there's two certificates that are floating around. The new one the adversary doesn't have, the old one that the adversary does have. But if the adversary continues using the old one, your browser doesn't know the difference, right? It doesn't know that this is the old one or that there's a new one. Kind of thing, okay? So it's not enough to just get a new one. You can get it like just to continue operating, but it's not enough. You have to cancel the old one as well. Okay, so this just illustrates that if you have a new certificate, the website will send the new one down, but then the adversary will just replace it with the old certificate. And so if the browser can't realize that this old certificate needs to be canceled, then there's nothing. This isn't helpful it doesn't prevent the attack. Okay, so we need to cancel, or the fancy term is revoke or revocation is the term that we use, and so that just is what we do. Okay, so we talked about one way of doing revocation, but I'll just go through it again. So the easiest way of doing it is you can just ask, basically, every time you get a certificate, you're going to ask someone whether it's valid or not. Okay? And the best person to ask would be the CA that issued it. Maybe they're arguably not the best. So for example, let's say you have a CA and they have really bad security and they got breached and someone was able to get a Google certificate from this bad CA. Okay? Now, in order for Google to get that certificate revoked, the bad CA would have to be the one to revoke it, right? But they're already a bad CA, right? We don't really know. They're not reliable, okay? So it's not ideal that the CA that issued the certificate that's being revoked is the one that's going to be doing the revocation. But that's what we're stuck with, okay? So the CA that issued the bad certificate, that's who's going to handle the revocation for you, okay? And so what they'll do is they'll put up a server, and you can find the location of the server in the certificate itself. So every certificate will say, where's the server to go ask whether the certificate is still valid or not. The CA, in theory, could put the server somewhere else, but they don't. They host it themselves. But in theory, you can write any URL into that certificate. And every time you get a new certificate, or not even a new one, like say you get it repeatedly, because it could be valid today, but it could get revoked tomorrow. So just because I checked today doesn't mean it's still valid. So I still need to check even if I've seen the certificate before, I need to check. I don't have to check like literally every time. So if I download 100 images from Wikimedia, I'm not asking 100 times whether it's revoked. I'll kind of remember it for maybe a day to 3 days, and then I'll start asking again, okay? But basically, I'm going to go ask the CA, hey, is this certificate still valid? And the CA is going to say, yes, it is, or no, it's not, okay? So the protocol is called OCSP, Online Certificate Status Protocol. This is a screenshot from the certificate itself. So you'll see if you look into the details of the certificate, actually I can just show it to you. So if we go over to Moodle, we click on the lock, we click Show Certificate. Now we're looking at the site certificate. So this is the certificate that Concordia has for their domain moodle.concordia.ca. If we go to details and scroll through, you see there's all sorts of stuff here, but the OCSP will be here somewhere. So it's down here, and then you can see there's a URL here. They don't host a website there; it's for a computer to go and ask for information. So there's nothing loading on the website. Actually, it looks like there's a file there. We could peek at the file and just see if it has any meaning. But yeah, so it's just a binary file, so there's nothing to see. But anyways, a machine, a computer could parse it. The browser could parse that information, and then it will respond. Okay, so there's two problems with this. The first one we mentioned is, let's say you're the CA for a huge site. Every time, maybe not literally every time, but every 3 days or whatever, every user that goes to the site is going to ask you about the certificate. So you're going to get a sort of a fraction, a ratio of the amount of traffic that, say, Google gets, you're going to now be getting at the CA with people asking you, is this Google certificate valid, yes or no? Okay, so what did happen traditionally is that the CAs couldn't keep up. They didn't have the infrastructure to keep up, and so their servers were often down. So you would ask and you wouldn't get a response, or you might 1 in 100 asks, you might get a response, and 99 times you wouldn't get a response at all. Okay, so that's a problem, obviously. So then the browsers have to decide, what am I going to do if I don't get a response? Okay, so the best case from a security perspective is we throw an error. We say, well, we can't tell whether the certificate's valid or not. We know it was issued, it's valid, like there's no other issue with it, but there is the off chance that it has been revoked. I'm asking the CA if it's revoked, they're not telling me yes or no, so I actually have no idea. So you probably shouldn't trust the certificate, and then they could throw an error. The problem is that these errors would tend to impact the largest sites. It would be the Googles and the Facebooks where you start seeing these errors. Users don't know, they don't have the complete picture of what's going on, so they can't really make an educated decision about whether you should trust it or not. And so what browsers decided to do was they would just try to do it, and if they didn't hear back, they wouldn't warn the user, they would give up, and then they would connect to the website anyway. They would still show you the lock and all of that type of stuff. Okay, so we call this is a general sort of security thing that we'll see a bit, but we call it failing open. So in a fail case, it fails open. Another place we saw fail open is when we talked about leaving a parking garage without paying, and we said if the power goes out, often the arm they'll leave it in an open position. Okay, so that's another example of failing open. So failing open is bad from a security perspective, but it's good from a deployability kind of perspective. Okay, so what do you do knowing this? Yeah.
I have a question.
Yeah.
You said the browser is going to ask the CA if the certificate is valid, and it goes through the internet, right?
Mm-hmm.
What protocol does it use? So this is the
Sorry, say the last part again. What?
the browser speaks to the CA to find out if the certificate is valid from Google or Facebook.
Yeah.
The protocol that it uses to reach the CA, the server that is put it in the CA's part, does it use the protocol, the secret protocol?
Yeah. So the protocol is actually here, which is a point that we'll get to in a second. But it uses HTTP. So it's not like some custom protocol. It's just a standard web request. And then you might, like we talked about yesterday, why does it use HTTPS? But we'll get to that in a second. But yeah, just in terms, it's just general HTTP. Yeah. Okay, so if you know the browser is going to drop the response, you see, let's go back to this picture. You're the adversary, you're in the middle, you have the old certificate, all right? So you drop the old certificate in. Then the user goes to the CA and says, is this valid or not? You expect that they're going to do it. You see that they're going to ocsp.ca's name, like you see that packet go out. It's over HTTP, right? What are you going to do? You don't want that, because if they actually are successful and ask the CA, and then the CA says, yes, it's revoked, then the user's not going to trust your certificate, okay? So what are your options as the adversary? Yeah, so you can just drop it. Yeah, so if you just drop it, then what happens? The CA doesn't hear about it, so they don't respond, right? The browser will eventually think, oh, the CA swamped, and then they'll just use the old certificate, they'll get the lock, and then it's successful, okay? So it's that simple. If you're already in the middle, you can just drop the packet. You could also drop the response. You could let the request go through and drop the response. It doesn't matter. But as long as the browser never hears about it, then it's going to fail open, okay? Okay, so it's very simple. So basically, revocation doesn't work in that case, okay? Now, the other thing we could push on is why HTTP instead of HTTPS? So does anyone remember the answer? Let's say you say that looks bad. Let's make it HTTPS, okay? So that's good. You're the Google engineer. You change Chrome. Now everyone's using HTTPS. Is it going to work or not? And what's going to happen? Okay. So we're going to enter a kind of deadlock situation. So I'll walk through it a little more slowly than I did last class. So what will happen is I go to Concordia and I get a certificate, and I don't know whether the certificate's revoked or not. So I go and I ask Global Signer, whoever it is this revoked or not? Okay, and then I hear nothing. I hear yes. I hear no. I'm not sure. Okay, but if I were to do this over HTTPS, right? Then I would go over to Global Sign, and before I could get their response, yes or no, I would have to open a tunnel to Global Sign, right? So I'll say, hi, I want to talk SSL with you. And Global Sign will say, great, here's my certificate. They'll send it back. So now, in order to validate whether the Concordia certificate is right, I now have to figure out whether this new certificate that I just got from Global Sign is right. So then I have to go into that certificate. I have to look up OCSP, and they'll say, oh, go to HTTPS, blah, 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 blah. So then I'll open another secure tunnel to that website, and they'll say, yeah, I'll do a secure tunnel with you. Here's my certificate. So I get another certificate back, right? And then I have to know whether that's revoked or not, and then I can never get a tunnel finished. You can't complete the tunnel until you decide on whether a certificate is revoked, okay? So you get stuck in this kind of infinite loop, and it will never resolve. Okay, so this strictly by definition, not strictly, I mean, the only way out of this loop, an alternative, would be if it came from a root certificate or a key that you already knew. Then you could just say, well, this is a root. And here's another question for you. I don't know if it's in the slides or not. What happens if a root CA gets stolen? Okay, so you want to revoke not just like some certificate, like Concordia certificate, but it's actually a root certificate that's in your computer. What happens if it gets stolen? I don't expect anyone to know the answer, but do you have a guess as to what might happen? Yeah, so it's compromised, but let me phrase it differently. How do you learn about that? So I need to learn that it's compromised. So it could be from the CA, but the thing about the root certificates is they're just keys. So there's no revocation check for a root certificate. So the only way you can do it actually is with a software update. So Windows or Mac or whoever would have to come up with a software update. They would remove the root certificate. And so if you're not updating your software, you'll never learn about it. But anyways. Okay, so HTTPS leads to this sort of circular dependency, so we have to use HTTP, okay? Now, it's really simple that if you're in the middle, you just drop the packet, okay? But another thing that you could do if you wanted to, like it's just easier to drop it. But let's say browsers like started enforcing OCSP, which now they do for like high level certificates. So like to get an EV certificate, you actually have to use OCSP. Okay, so they're not going to fail open for a certain class of certificates. Okay, so what are you going to do as an adversary if you can't just let it fail? You can't drop the packet anymore. Well, if it's over HTTP, you can change it. Okay, so you let the request go through, and then the CA says, yeah, it's revoked, and you change it to no, it's not revoked, and then you pass it on to the user, and then the user, it's the same outcome, right? You don't even have to wait for the response. You could just make up a response. Like once you see the request, you can not forward it to the CA and just answer as if you're the CA anyways. Okay, so anyway, so this whole revocation thing basically doesn't work. Even if you start enforcing OCSP, it doesn't actually solve the problem. And there's no way to easily turn on HTTPS. And so it's crazy that like 30, 40, 50 years later, we're still using this system, right? But it's just, I guess certificates don't get stolen enough. And it's also like a big assumption to assume the adversary's in the middle. And so like putting all those things together, it's kind of a rare corner case. And so people don't seem that incentivized to try and solve it. Okay?
We can use some encryption that works at a different layer of the OS side. For example, IPsec or VPN. What happens then? Because it's getting encrypted at a different layer, right?
Yeah, sure. So all encryption requires authentication. So it doesn't matter where you do it. You still have to solve the problem of how do I know my tunnel is to you, right? And so you still have to cough up a public key. And I still have the question of how do I know it's your public key and not the adversary's? And so you're always stuck with certificates regardless. So IPsec has certificates, DNSSEC has certificates. Like, so they all, yeah, anyway, so moving the protocol around in the stack won't solve this particular problem. You still end up where we started, which is with certificates, certificate authorities, and revocation. Yeah. Okay. Okay, so this is just showing that you can ask whether it's valid or not, and then the global sign says no, and then the adversary just switches it to a yes. Okay, there's an option number 2. So option number 2 is it looks, at first glance, it looks kind of the same as option number 1. It's called a certificate revocation list. So again, the CA, we're starting with the CA. The CA is coming along and they're saying, here's all the certificates that we've revoked. It's a list, okay? So in OCSP, it's more like a one-on-one query. So you're just saying, I just want to know about this certificate. Here you're saying like, okay, tell me everything that you've revoked, okay? Now the nice thing about this is you can wrap a signature on the list, okay? The CA can use the key that's in their certificate. And so you can test, like you can see whether it actually came from the CA. So it kind of gets around that HTTPS, HTTP kind of problem. So what browsers started doing, Chrome in particular, is they said, if we leave it to users to go and fetch these CRLs, like it's not going to work that well. So what we're going to do is we're going to pre-fetch them ourselves. And we're going to build a list, like a master list of all CAs. And we're just going to push it to all Chrome users. And it will come down as this thing called CRL set. And it's not over HTTP. Like it's just like some direct Google headquarters to your browser, like some custom protocol. And your browser will just fetch it every day or two. I don't know how frequently it happens. And then now you have an updated list that represent all revocated certificates for all CAs. Okay. The problem with this is that the coverage was like not very good. So not all CAs had the list. They might not have had them in a known location. There were all sorts of issues, like in terms of Google being able to fetch it. And so this is really old data. So I'd like to update this slide. I couldn't find a more recent study. But as of 2014, basically the bottom line you can think of is on Mac, the Chrome on Apple, the number of certificates, the number of CAs that is not covered in this CRL set is 75%. Okay, I don't know how many there are revoked within that those CAs, but the point is there was only 25% of CAs that were included, and then on Windows 85 was missing, and so basically they were only getting small coverage of all the CAs that were involved. Now, if some of these CAs are the biggest CAs, then it might represent a larger proportion of certificates. So numbers are numbers, like they can lead you to wrong conclusions or whatever if you don't study them very, very closely. But the bottom line is that the CRL thing it's a good idea in principle, but in practice it wasn't working very effectively. Okay, the third idea is basically it's sort of a combination of CRLs and OCSP. So the idea would be, let's say you're going to Google as a user. You're supposed to check whether this Google certificate is valid or not. And so let's say everyone in this class, we all go to Google at the same time. Then there's 100 checks against that CA's website. So that's bad because of traffic, okay? What if Google went to the website and said, can you tell me whether the certificate's valid or not, right? The CA says, yes, it's still valid. They sign it. And then what Google does is when someone says, I want to connect to you, they say, here's my certificate, and here is a signed statement from the CA basically saying that the certificate is still valid, and it has a 3-day validity or whatever. So it's kind of like a mini certificate as well. So you have the long-term certificate from the CA that lasts for 2 years, and you have this shorter statement that's valid for 3 days. And then the CA only has to sign it once for Google, and then Google can push it out to all their users instead of having to answer for everyone else, okay? So this is the best solution for sure. Technically, and then you don't have to download an entire list of every certificate from the CA. You don't have to know all 600 CAs to go ask them for their lists and all that type of stuff, okay? It's still like you're just getting the revocation information for the website you're actually visiting, the only website that you're interested in. It's fresh information. It doesn't have the problem of creating a lot of traffic for the OCSP responder. So it basically solves everything. The problem is, like, where do you put that data in the handshake, okay? So what they said is, well, they spent a long time looking at HTTPS, and they said there's a couple fields in the headers, and they're sort of arbitrary length, and so we can kind of put it here, and as long as the browser can parse it, then the browser will parse it out correctly. And so if we can get all the browsers to understand this, and so they had a standard for what it would look like. But then when they went and did it on the web, there's all these like middle boxes in the internet, and the middle boxes, they're supposed to just kind of look at the IP address and say go left or go right, but they don't. They tend to go a little deeper. They do some deep packet inspection. They make decisions on what they were seeing and things like that. And because there was this weird field that they didn't know about, then they would just drop the packet sometimes. And so basically the response was that it breaks too many, like for too many users trying to access things, these middle boxes are breaking the protocol. And so we shouldn't turn it on. If we turn it on for everyone, then a lot of people are going to have errors and things like that. So the idea kind of died. It was a great idea, but it died for practical reasons. And it's hard to go out and find who owns these middle boxes and get them to upgrade. And they're real industrial like strength, like computers. So it's not trivial to upgrade them. They're probably written Fortran or something like that. And so anyway, so it was just thought to be too big of a deployment kind of issue with it. Okay. So actually going back to UDS frameworks, right? Deployability was one issue. So if you're like, I have a great idea, but I have to change every middle box on the internet to make it work, it's going to die because of deployability, right? The security might be great, the usability might be great, but that deployability problem will make sure it doesn't work. Okay, so what do we do today? And so the answer is we still do. I mean, Google keeps doing CRL set in Chrome. I don't know that other browsers have adopted it or not. And we still do OCSP. It's still over HTTP, and it's just sort of, everyone does it, and that's fine. And no one really pays attention to the fact that it is not secure. Okay, is there any questions about revocation? Okay. Okay, so another idea, sort of big idea, is that we could try to, instead of using a revoked certificate or an invalid certificate or getting a valid certificate, we could try to just not use a certificate, period. Okay, so we talked about one attack, I think already, where you just send a bad certificate down, the user gets an error, and then they have an option to click through the error. And so if you can get enough users to click through, then it doesn't matter. Okay. This is another thing that's changed a lot. So people understand this attack now well. So it doesn't really exist. So I couldn't find a modern website that implements it, but I wanted to cover it just so that you know why things are the way they are. So we're going to pretend, this is going to be hypothetical. So if I go to concordia.ca, I actually get HTTPS right away. Okay, so that's what happens. Okay, but what used to happen for lots of websites, all major websites that had logins, is you would have a website like this. It would come down to you. This is called the landing page. So the first page you see is the landing page. So the landing page would actually come to you over HTTP. Then there would be like a box to log in. It might be a button to sign in, or it might actually just take your username and your password right on the top of the screen. Like put your username here, put your password there, hit the button submit. Okay. Now, so my question to you is, if the landing page came down over HTTP and you put your username and password and hit submit, does the password go back to the website over HTTP, or is it possible that it would go over HTTPS? Okay, so let's say it's possible. What would you have to do on that website to make it work that way?
Like I have to configure the API with HTTPS to trigger to send the username and password.
Okay, yeah. So what will happen is that submit button is tied to like an HTML action. Okay, so there'll be like a form submit or whatever. That's in the code of the website itself. And what the website says is, put a text field here, and if the user fills it in and presses this button, take that information, wrap it up in a post, which is a kind of HTTP message, and send it to this URL. This is the URL that I want it to go to. And if you put HTTPS in that URL, then it will go over HTTPS. And if you don't, then it will go over HTTP. Okay? So the question is, how do you know, you're a user now, how do you know whether it's going to go over HTTPS or not?
By inspecting the developer.
Okay. So, yeah, so let's say that it's, I don't know, well, whatever, it's some website. So I'm going to tell my mom, hey, you shouldn't send your password over HTTP. So if you see one of these things, just right click, go inspect element, try and find the button like in the whole like HTML, make sure it's HTTP instead of HTTPS. So that does work absolutely for engineers, right? But what about for regular users? Is there a way a regular user could know?
I think if you hover your mouse over something.
Okay, so sometimes if you hover over, it could, like the tooltip could display a URL. Then you could check whether it's HTTP or HTTPS. So that might be one way. It's definitely easier than inspect element. It's still something that most people wouldn't know to do, probably. What if there's a lock on the submit? Like often the submit will have like a lock on the submit button itself. So that means it's secure, right? If like on the button itself on the website, it says the word submit and then there's a lock beside it, then when you push the button, it's secure. People are nodding, but I'm trying to trick you. It doesn't mean anything. It's just an image that's on the website, right? You can put locks beside anything. It doesn't change anything at all, okay? Okay, so the idea for these websites is if you're sending a password or doing something sensitive, they would switch you over to HTTPS. But the only way of doing it, as mentioned, was you have to inspect element. You'd have to go through the HTML. You would have to find, like, okay, here's the button here. The sign. You can see the word sign in here, and then you can see the URL is HTTPS. And so then that's good. But no one's going to know how to do that, right? Okay. Now, let's say you're an adversary, and let's say there is a website that's like this. Okay, so there is a website where the landing page comes down over HTTP. The sign-in is wired up correctly. So the password will actually go over HTTPS. If the user puts the password in and hits submit, it will go over HTTPS. You want to get that password, so you're not going to be able to get it because it's wired up that way. Are you out of luck then? Is this secure, or is there anything, can anyone think of anything that we could add to our attack tree that you could do?
I can do phishing.
Okay, so forget about phishing. We'll come back to that. But let's say that you're doing it, it's on the actual website itself. But you are in the middle. So always, the adversary is always in the middle.
Can you get the code from the website?
Yep. Okay, so the index.html, is that coming, the landing page, first off, is it coming over HTTP or HTTPS?
It's coming this page.
Okay, so can he see the source code, or she? Okay, so the adversary can see it. That's a good step. What can they do?
That will replace the
He can send back the response like this password is invalid.
Okay, so you could do something with invalid, but if it's going over SSL, you're not going to be able to do anything. So you want to stop it from going over SSL, basically.
Can it change the URL that is going back from?
Okay.
This URL?
Okay, so let's say index.html is coming down. Okay, this URL says https hub.concordia.ca. The adversary can see it and change it because it's not protected. So what if they replace HTTPS with HTTP? Then what happens? Okay, what looks different about the website? The user's looking at the website now. It's been modified by the adversary. How does it look? Exactly the same.
encrypted password will not be sent. It will be clear text, so I can see it and I can use the encrypted password.
Okay. So let's go through this a little slower. Okay, first off, the website looks exactly the same. So there's no difference. If you went into inspect element, you might be able to find the difference, or if you hovered your mouse over it, you could see the tooltip. But if you're not a sophisticated user, there's going to be no difference to you at all. Okay? Okay, then what you'll do is you'll type your username, you'll type your password in. Do the stars still appear over your password as you're typing it in? Yeah, so that all looks the same. I hit the button submit. What happens? Okay, so your password will go over clear text. Now, sometimes your browser will warn you. Okay, it will just say for anything you put over a form submission that is not encrypted, it will warn you. Okay, so you could get that warning as a browser, but again, users might just click through that warning. Okay. The other thing is that you could just not use HTTP posts. You could use JavaScript or something like that. So there would be ways of communicating the password that would sidestep that whole warning. Okay. So basically, the user wouldn't. There are ways that you could change it so that the user wouldn't notice it. Okay. Now, does this have to be a custom? Is this attack customized for this website? So I do have to know where that button is. I have to know what URL I'm changing, right? So to me, I don't know, sitting here, it seems like this is a custom attack, right?
Look for form solutions with HTTPS and try to.
Okay, you could even go even more broad, just replace everywhere you see HTTPS in the HTML of the file, just replace it with HTTP, okay? Form submission, image download, whatever it is, doesn't matter, just replace it, okay? And so if you do that, then basically the user will get an HTTP website and they'll never leave HTTP. Everything they click on, doesn't matter. They click it, they submit, whatever they're doing, they always stay on HTTP because there's no even references to HTTPS left on the website anymore. So there is a tool called SSL strip that does that. SSL stripping is the term for this attack. And it's really simple. You just sit in the middle and yeah, you just strip out every reference to HTTPS and replace it with HTTP. And then users never leave HTTP. And so you can continue, basically the tunnel never gets established. Now the user might catch on once they click submit. What would happen normally is you would submit your password, but because it goes over HTTPS, when the response page comes back, now the lock would appear. Okay, so the user might catch on that like, oh, I just hit submit and the lock didn't appear on the next page, but by that time it's too late, right? The password's already gone. It's gone in clear text, and so yeah, so then it's already done. Okay, so once you're on HTTP, someone that's in the middle can keep you on HTTP. They can make sure you never leave HTTP. And the only option really...
Authentication mechanism should work. Like I am accepting my user credential on my HTTPS API.
Yeah.
And attacker changed that HTTPS API to HTTP. So my server, authentication server, will not accept that.
Agreed. Great question. So isn't the server going to complain in this scenario? Okay. So look at it's not drawn exactly right, but see the adversary in the middle. What they're doing actually is they can have an HTTPS connection to the server, right? So like from this point, between the adversary and the server, they can run HTTPS. Between them and you, they're running just HTTP. And so all the traffic that's coming to them, they're then putting into a tunnel to the server. So the server is none the wiser. The server, it looks normal. But yeah, you're absolutely right. So the server is expecting things over HTTPS. And so that's what the adversary that's doing is clever, is they actually have an HTTPS session between them and the server, and they're just relaying the information back and forth. Now, one thing about these attacks that comes to mind that I haven't mentioned before is the adversary can't leave. Once they leave, then all of a sudden you're sending raw HTTP, and the server's like, I don't know what you're talking about, right? Or this session ID doesn't match my session ID or whatever, right? So once you're in that position, if you leave, the connection will get dropped. But that's usually, I mean, connections get dropped for all sorts of reasons, right? And so it probably wouldn't be that suspicious to it. And most interactions, you just want the cookie or you want the password. It's going to happen in the first couple seconds anyways. It's not like you have to sit there for 4 days. And most sessions don't last 4 days anyways. Okay, so how do we solve this problem? So what we want to do is we want to move the landing page to HTTPS. So the very first thing you do is you try and get the HTTPS page, so there's no HTTP. And then how do you know to get the HTTPS page in the first place? That actually goes back, I don't know if you remember, but like 2 weeks ago, I had a slide with like, how do you even get onto HTTPS as opposed to HTTP in the first place? Let me see if I can actually find it. And so it's basically like, well, someone linked you to the website, or you asked Google for it, that kind of thing. Yeah, so here. So like, you could explicitly type it in. You were on another website and it linked you to it. So as long as that website was on HTTPS. Now you might say, well, don't you need HTTPS all the way down, right? Well, the thing is that usually you start with Google. Like a lot of search, like a lot of like browsing would start with something like Google, and that's like hard pinned into Safari. So as long as you start with Google, you're never going to end up on HTTP Google, you only end up on HTTPS. And then Google's only going to send you to other HTTPS websites if they support it. And so you'll just never leave HTTPS. Okay, so that's usually, it's actually like hard now to get onto HTTP and kind of stay there. Okay, so here's another kind of weird, this is like very esoteric, but I thought it was fun, so I would throw it in. So the resolution of this picture is really, really bad. But pretend this says www.paypal.com. There is a lock. This is an EV certificate, so it's green. It has paypal.us or whatever. Is it safe to type your password into this PayPal? So there's a user, it's asking for your email address, password. So I put my email in, I press my password, I want to press this login button. When I press that login button, is this going to go over HTTPS based on everything that I'm seeing?
This is the lock, right?
Yeah, so let me phrase it another way. Based on everything I see, It would. There's nothing weird about it. It's not a trick question in that sense, like, oh, there's not actually a lock or whatever.
Looks like the API, the same problem that we saw in the previous case.
Okay, but we're already on HTTPS.
But still the request,
Yeah, once you're on HTTPS, you
can actually.
you could form submit it over HTTP, but anyways, it's the opposite was very prevalent, and that's like a developer error. You're always subject to like websites being programmed wrong. So that's not the answer, anyways. But someone else was saying something.
No, it looks safe, according to the
Yeah, it looks safe. Okay. Okay, so this is absolutely not safe, but it's for like such a weird, ridiculous reason. Okay, pretend I like grabbed this window and I started to like move it around, but somehow it wouldn't move outside of this gray zone. Okay. Could this be a picture on the outer website? This looks like a pop-up, right? Yeah. Everyone remember pop-ups? Okay. So we don't have pop-ups so much anymore for this reason. Is this actually a browser window? Okay, maybe it is, maybe it isn't. How could you tell? So if I try and drag it outside of the website, it should go outside the website, right? If it doesn't, is there a chance that let's start with the idea that it's an image on the website. Is that possible? So sort of it's possible, but as soon as I put my username and password in, I'll click on it and nothing will happen. Okay? But in HTML, could I create something that looks like an iframes and things like that? Could I create something that looks like this? Absolutely, right? It's just pixels, right? So I can create it. I can have a text field here, right? I can even have it so if you click on the certificate, it would pop up another window that would tell you about the certificate or whatever. Like, so your imagination's the limit. It depends on how much time you want to spend, okay? So sometimes you see this kind of thing. So just in terms of terminology, like where I'm putting my mouse, the stuff that's sort of like there's the website content itself, right? Which is everything that's in roughly this box that I'm sort of drawing out with my mouse. Okay. And then there's a bunch of stuff on the outside. So the outside we call Chrome. Okay, so that's actually where Google Chrome, like the name, comes from. But it's called the Chrome of software applications. So it's all the buttons and the menus and all of that type of stuff. Okay, so what we're doing here is we're spoofing the Chrome of the browser itself. We don't see this so much anymore because we use tabs. Okay, so things open in new tabs instead of pop-ups. And a new tab will force you, like the new tab opens in the Chrome of the browser. It doesn't open on top of the content of the browser itself, okay? But sometimes you'll go to websites and there's other things that they might spoof, like the operating system. Like you get error messages sometimes in the operating system. So you go to a website and one of those things will pop up. And it looks like the operating system is warning you about something, but it's actually just 100% the content of the website itself, okay? So we call this pitcher-in-pitcher attacks. Basically, the way it would work is I'd have to lure you to the outer website somehow. So that could be through phishing. It could be through any type of technique. And then once I get you to my bad, evil outer website, then I can pop up this window inside the content of the website that looks like a pop-up. And then everything you see here is spoofed. Okay, so nothing here is real. And whatever I type across here, whether it goes over HTTPS or not depends on whether this outer website is HTTPS or not. Even if it's HTTPS, then it's still coming to me because I control the outer website. So, yeah. And someone mentioned iframe, so I just want to specify that you could iframe it where that's really PayPal's website, okay? And in that case, it's actually safe. So you could put a password if that was iframed. So this isn't an iframe anyway. So this is a complete spoof of what PayPal's website would look like. Everything is fake. Iframes will come back later because we're going to go through the security model of, let's say you have an iframe like this, and you put your password in. Does the outer site see the password or not? And do the cookies get shared between them and all that kind of stuff? that's also like a area to explore in terms of browser security. Okay, so pop-ups were deemed sort of dangerous because of this. So now we try to use tabs instead. So it's very rare, or it's basically you never see a pop-up. You might see a pop-up within the website, like where the website is popping something up for you, but you'll never see a new window emerge that's smaller than the big window that you're using. It will always open up in a tab. But then what people do is they also will spoof things like browser, or sorry, operating system error messages and things like this. So these are like some of the spoof things. Now, they can't really get you to do much. Like you can either click OK and it goes away. You can click stay on page or leave page. So they don't have control over what those buttons do. So the scam involved has to be in the content of the message itself. So if you read these closely, you would see there's some phone number that you're supposed to call. And so that's where the scam is. It's on making that phone call. This window itself isn't dangerous in and of itself. And clicking on it's not dangerous either. Okay, so any questions about this? Okay. So this was the sort of third piece of the attack tree. So we started with what could you see if you just look from the outside of the tunnel? How could you break into the tunnel itself? That got into more cryptographic attacks. And then how could you get the tunnel pointed at you? To get the tunnel pointed at you, you could try to get a real certificate for a bad reason from a CA. So that was all, there's a whole subtree there that I've collapsed. But then you could also use an invalid certificate. You could just say, I'm going to tolerate the error. Most users will click through. It could be like somehow there's an implementation flaw, so things aren't being checked. Then you could exploit the implementation flaw. So for example, basic constraints not being checked. So you could use a site certificate as if it was a CA certificate. You could send a certificate for the wrong domain, and if that go-to fail was still a problem in the user's implementation, then you would have a problem. If there's some sort of way of exploiting the parsing between CAs and browsers, they're different, then there might be a way to exploit it. There's another thing involving hash collisions that I didn't cover, so you can just sort of skip over that. You could also use a revoke certificate. So you steal a certificate, but then now they're going to revoke it, so you're not going to be able to use it anymore. But then you can defeat the revocation. Either if it's going over OCSP, you can just drop it, or if the browser starts enforcing it, then you can always just change the response from yes to no. And then you can look at ways of using no certificate. So you can do SSL stripping, where you're trying to keep them from ever leaving HTTPS. You could spoof the browser Chrome, so the picture-in-picture attack. Another thing I didn't mention is you could. So this also is something that's sort of changed, but you can see this is Moodle's website, okay, and you can see the name of this website is course INSE 6150, and there's this little logo beside it, right? So this logo is called a favicon. And so they were popular, I don't know, like 10, 20 years ago. Everyone had to get a favicon for their website, okay? So it's still a thing. But browsers used to actually put it up in the URL bar itself. So you would have the URL bar, and then they would display the favicon there. And so what you could do is you could put a lock there as your favicon, and it kind of looks like a lock to the website itself. But it's not, but it's close enough to it. Now, if you had a lock down here, still, I think some users might see the lock there and think this is a secure tab. But anyways, they at least moved it far away from where the actual lock appears generally for that reason. The problem with it is there's no real attack there because you can do it for your own website, but even if you had a real lock, you would still have the tunnel pointing to you because it's your website. So you can spoof it, but it doesn't really amount to much. So it's not a great attack, but anyways, I threw it in the tree as well. Okay, so if you want to see the full attack tree, it's on Moodle, or you can, I put it on my website as well, so you can just link to it. So this is everything that we talked about for the last 3 weeks. So there was all, I'm not going to go through it all, but anyways, it's the high level things were what could you see from outside the tunnel, how could you break into the tunnel, and then how you could subvert server authentication. So these last 3 nodes are what we talked about today, and a bit of last class. And then the subtree that was missing was the obtain a valid certificate, which gets into like email-based verification and things like that. Okay, so what's the sort of high-level takeaways of doing this exercise? So we spent a lot of time on this, right? So like, what did we learn? So we learned a lot about HTTPS. We learned that it's maybe not as secure as we thought it was, okay? But in terms of attack trees, like using attack trees to model this, what are the kind of key takeaways from it, okay? So the first thing was, I wanted to sort of show you that in order to do an attack tree, you can, like, even though attack tree is a high level methodology, you can go into a lot of details. Like this, I wouldn't call this high level, right? There was a lot of details that we had to learn and things like that. I couldn't teach this in half an hour, okay? So it's not really a high level methodology. So attack trees are pretty flexible. You can go into the deep details if you want. It won't stop you. In order to do it well, you had to understand HTTPS. Okay, so I spent a lot of time teaching you how HTTPS worked, and then we would look at how you attack it. So this is how it works, this is how you attack it. But if you didn't know anything about HTTPS, like say 3 weeks ago, I said, you've all heard of HTTPS, come up with an attack tree, right? You're probably not going to come up with, you might get a couple of these attacks and you could go read about it, but you're not going to come up with something this thorough. And there's people out there in the world that would look at my table and say, oh, that's missing like 50% of the attacks that I can think of, right? So the more domain knowledge, the more expertise you have, it makes a better attack tree, okay? So methodologies aren't this like one simple trick, you know, where you can determine if something's secure or not just by, just do an attack tree, right? Like you have to know about it, you still have to sweat the details, you have to learn the attacks. All it does is really kind of help you organize it and things like that.
Professor?
Yeah.
Like we have attack tree to think about all types of attacks and situations that can happen. There is something that some strategy or technique to respond to this. I mean, to say, okay, to this branch we can do that thing. Just to say if we are able to cover all the holes.
Right. So I don't know that anyone's user tested this as a methodology to see like how normal people do it. There is no, is there an attack that I missed? Probably, right? And this doesn't tell you that, right? So it tells you the attacks I thought of. It doesn't tell you what's missed. The one thing it does is, so it's sort of the third point is, by putting some structure, it can help you think about new attacks. So like the best way I can put it is actually just go back to this. So you can see there's sort of a pattern, like obtain a valid certificate, obtain an invalid certificate, obtain a revoked certificate, like use no certificate, right? What did I miss? Well, maybe use an expired certificate. So because I have that structure, it's like, oh, well, what about expired certificates? Or what is there any other kind of certificate? So that's kind of where it could help you see things that you aren't seeing already. But if you don't put the structure in, then you won't notice the patterns or whatever. Yeah. So it's not a magic methodology that will help you see something that you're not going to see anyways, but it's better than nothing, we'll say. Yeah. Okay. The other thing that I really like about attack trees is that these aren't all technical attacks. A lot of them are. Some of them is just like guess a password, right? One of them is like get a government to like use the legal system to get like a key from a CA. Okay. Another thing was like go into a CA and say you work for Microsoft even though you don't. Have a fake ID, dress up like someone that looks like they're from Microsoft, I don't know, and try and convince them. Okay. So you have social engineering, you have a legal attack, you have like guessing passwords, which is one of the most basic attacks that you can think of, you know, and all of these things are sort of hanging out with like, you know, go into this encryption method, and because it's like CPA secure instead of CCA secure, you can attack the initialization vectors or whatever. Like there's like really deep deep crypto attacks, and everything can stay together, okay? So an attack tree should encourage you, and also even with the, like attacking the parking gate, like the mechanical arm and things like that, it tries to get you to think about everything, okay? Because adversaries aren't going to limit themselves. If they can just walk in to somewhere pretending to be someone, and or call someone up and pretend to be someone on the phone, they're going to do that instead of like trying to break the crypto that's involved, right? So adversaries will do, it doesn't care, they have a goal, it doesn't matter how they achieve it, they'll achieve it any way that they want to. So anyways, attack trees are a lot of methodologies lock you into thinking just technically, or even subsets of technical, like you're just thinking of all the cryptographic attacks, right? But from security, you don't want to just think of the cryptographic attacks. You don't want to just think about the technical attacks. You want to think about all attacks: technical, non-technical, cryptographic, non-cryptographic. And so this is a methodology that lets you do that. Okay. And then the final thing is that the attack tree also kind of tells a story. So if you were to pick one of these nodes and kind of go from so I'll just do it for one. So let's say my goal is to observe traffic sent over HTTPS from a man in the middle position. I'm going to do it by getting the tunnel pointed at me, okay? Well, I can't get the tunnel pointed at me because I don't have a certificate. So what am I going to do? Well, somehow I'm going to get a certificate, okay? So now I have an actual certificate. Well, I can't get a certificate because I'm not Google, right? Well, I'm going to subvert the way that CAs issue certificates. So I'm going to try and get the CA to think I'm Google, even though I'm not Google. And I know they have this automated verification where they just send an email, okay? And so the way I'm going to trick them into thinking I'm Google is I'm going to steal the password for admin@google.com, okay? And then that's it. That's an attack, right? I got all the way there. I steal that password, and then you can go through the details of like they send the password and things like that. But at the end of the day, I walk away with a real Google certificate, and I can achieve my goal. I just drop it in every time I see someone connecting to Google. I give them my certificate instead. Now the tunnel's pointing at me, and then I can read and modify their content. Okay, so attack tree is nice in that sense that it sort of spells out scenarios when you read them from path to leaf. And if it doesn't, if you're not getting closer and closer to the attack, then you're maybe structuring your attack tree wrong. Okay, so they're supposed to kind of look that way. Okay, is there any questions about attack trees, about HTTPS, about anything up to this present moment? It's your last chance, because once we're done with this, it's on to a brand new topic. Okay, good. All right, so what we're going to do is I set aside 3 lectures to cover this. We did it in 2.5 or whatever. So we're going to take a break, an extended break. So we'll end class now early. Next week, remember, it's reading week. So you won't have a class next week. And then the week after, I mentioned at the start of class, but not everyone was here, there's a chance I'll be away. If I'm away, I might pre-record the lecture. And if I do it, I'm actually going to pre-record 2 lectures because they kind of go together. It's kind of like this. It's like a continuation. I'll give you all of that stuff, and then the week after we'll have like a question and answer in class, okay? But what happens after next week will be sent by email. So my plans aren't 100%, so I'll be reminding you so you don't have to remember it. The only thing to remember is don't come next class, because if you do, I won't be here anyways. I don't know how many other people will be. Yeah, and enjoy the week, and I hope if you have midterms in your classes, I hope they go well, and I hope your assignment goes well if you haven't submitted it.